Okay, so I want to accomplish a couple of things in a couple of videos, 2 or 3 videos. I don't know how many it will take, but I want to show you how to use Markdown in Jupyter. That is, how to write LaTeX and just kind of plain text, non-code in Jupyter, and how to get it to compile so that it looks right. But I also want to talk about a package called SymPy. Now, SymPy is something that David Manuel talks about in the Python videos that I linked to that I've put in one of the modules. It's a symbolic Python thing that will be very helpful in doing classroom stuff. So it's in the videos that he's made, and also if you look at the link that I posted to my my notes for my ODE class, they're also listed in there. I also have Jupyter documents going through very, very explicitly how to use SymPy. So we'll do this probably in 2 videos. The first video I'm going to concentrate on showing you how to use Markdown, and the second video I will kind of concentrate on showing you how to use SymPy. So for now, what we've been doing so far is we've been typing stuff in the lines here, and if we wanted to type exposition, maybe we could do it inside a comment or something like that. But what I want to do now is actually put exposition. It's not just a comment, but it's going to read like a document that you would give to somebody. So I'm going to come out down here to Markdown. If you've had experience with HTML, this is easier than HTML, but there's a lot of similar ideas. Like you put in different symbols to tell the computer how you want it to interpret different parts of text. So for example, if you want a title for the document, you do the pound sign here, or the hashtag sign. I don't know what the popular thing to call it is now. And let's say we want to talk about quadratic functions. And I can't remember if I told you, but you need to change this right here from code to Markdown. So we have quadratic functions, and I'm just going to press enter, and now I'm going to start typing kind of just plain text. Today we will learn about quadratic functions. Okay, so now what's going to happen, we don't want it to look like this, but when we run this cell, it's actually going to interpret this as a title, make it look like it's a title, like it's a heading, and it's going to interpret this as text. So it's going to make it look like plain text. So you can either click run or do shift enter. I'm going to do shift enter, and this is what we have here. There's other things if we want to come up here, like a subtitle. If we have something like this and run it, we get something like this, and so on and so forth. There are other things that we can do as well. So let's say I want to have quadratic functions, but I want to have it like bold. So you just do 2 underlines. And now you can see here, kind of as you're writing, it's sort of a what you see is what you get type of thing. It's more like a what you see is a prediction of what you're going to get. But now when you press enter, it's bold. If you want it to be italicized, you can do 2 asterisks. Actually 1 asterisk. And it looks like if you do 2 asterisks, I'm not really sure. It looks also like that's bold. So anyways, there is a cheat sheet for all of the different things, all of the different Markdown symbols. And I will put that in one of the modules. But the good thing is we can also talk about LaTeX. So we can also use LaTeX in here as well. So let's say I want to say today we will learn about quadratic functions, and now I want to tell you what a quadratic function is. A quadratic function is a function of the form, and I'm going to go to a new line. Let me just do it like this now. So I'm going to put my math in the dollar signs here. F of x, actually I'm going to do P of x equals, let's see, how do we want to do this? A plus bx plus cx squared. Okay, for real numbers a comma b comma c. Okay, now when I run this, hopefully this is going to look like what we want it to look like. And it does. So now we have this presented in kind of nice math type. But let's say that we don't want to have this in line. Let's say we want to kind of have it centered. So what we can do now, whoops, will look like this, and we'll do double dollar signs. And so when we run this p of x equals a plus bx plus cx squared will be centered, and then this will be on the next line. So shift enter, and this is what we get. Okay, now we can also put code here. So for example, 1 plus 2, when I run this, is going to say 3. Okay, so we can still do code. So the idea is that with Jupyter, we can mix the LaTeX and Markdown with code, which is good pedagogically. It's just good for a number of reasons. I mentioned this in the intro video. I mean, and also if you look at the Jupyter notebooks that I've done for my differential equations class, this is all written completely inside of Jupyter. Okay, so I have both the exposition about differential equations and numerical methods and things like this, what the code is doing, etc., and the code in the same file. It's a lot easier than doing basically anything else. Okay, so in the next video, I want to look at some basic SymPy stuff. Again, your main resource for the SymPy stuff is going to be from Professor Manuel's videos and from the documents that I've posted, that I've linked to my differential equations webpage. These videos are just kind of get you started to see what's going on. And really, the main way that you're going to learn how to do this is just playing around with stuff on your own.